Hello, IB Environmental students. Today we're going to be picking one of the Your Turn sheets on Google Sheets to practice. Most of us are probably going to be picking this one because unless you did plant identification or macroinvertebrates, this is probably the right one for you to be practicing. Alright, so here we're going to be practicing with pretend data on soil pH along a 25-meter transect away from a stream. Right, in our strong table title we have a number. We have an uncertainty on the probe we used. All right, we have titles and headings with units. We have distances, and we have 5 trials all here. We have a consistency in the precision of the number of decimal places. All good stuff. So I'm going to start by making my process data title for table 2. All of table 1's title is actually hiding in this one cell. I know it looks like it's going across, but it's right here, and to fix it, if I needed to fix anything, I would type right up here into this function column or function row. I'm going to just copy and paste this over by clicking on that cell and going Control C and copying and pasting it down here, Control V. Now that it's in A17 also, and I have A17 highlighted, I'm going to start changing some stuff. I'm going to now call this new one Table 2. I'm going to say soil pH levels, but they're going to be average soil pH levels that we're going to do. And we're going to have how many trials? N equals how many trials are going to go into it? 5. And we're going to also have standard deviations. But other than that, pretty much the titles are the same. Right, and that's my table title. So other things that we can do, all right, is there going to be any difference here at the beginning for distance along a transect from my upcoming table? Nope, that's all going to be the same. So I can kind of highlight this big thing here, distance, and these 5 distances. I'm going to hit Control C, and I'm going to copy that down here. Boom, copy paste with Control V. Very nice. If you're not really good at Control C and Control V, you can hit copy and then paste. Alright, and what's my first row going to be? Well, I need to type in here that I'm going to be doing averages. And then what's another thing I have to calculate? Standard deviation. I can be lame and just abbreviate it as standard deviation. Now I'm going to use my skills from the previous video to quickly be able to do this really fast. So for averages, I can go up here for the average for 5 meters. I'm going to click on 5 meters right here. I'm going to go to the function, the equal sign. I'm doing averages. I'm going to highlight what I want to do. Boom, shakalaka, there's my average. Much easier than typing all of that into a calculator, right? If I wanted to make sure I put this more centered, see that it's kind of on to the right, I can go to this align centered, and that's how I do that. If I wanted to change how many decimal places, I can go change the decimal places, increase or decrease. Decrease would make one go away and it would round it, etc. But I have 2 decimal places here and 2 decimal places there, so that's okay. I'm going to quickly do averages for here too. Oop. I can type in here just like how I can type up there. Average. What am I averaging here? This section. That's great. Now, remember, if I'm doing the same pattern, right, I'm always doing row 8 through row 12. For both of these, what was my ninja trick? Oh yeah, I can drag it across. And look, all my calculations are done. They're all highlighted here. I can all move them to be more centered so it's prettier looking. Very cool. Next, I want to do standard deviations. Standard deviations are not going to be quite as small as my first example on the previous video because I see a lot more variation and spread outness for each level of the IV. So here I'm going to click on standard deviation for 5 meters. I'm going to go up to function, go equal sign, standard deviation, highlight the section I want to do. Boom. Now notice now I have a bajillion decimal places. Yes, that's scientific. I do not want to have extra decimal places compared to this. So I go to, no, decrease the decimal places until I have the right number of decimal places. Move it so it's right underneath. Double check I have an equal amount of decimal places. This means that within here I have lots of variation of about 0.25. That's a lot more than I had in my other example. I'm going to do one more practice here for 10 meters. Equal sign standard deviation. Highlight the area that I want to do it on. Those trials for 10. Boom. Again, I have too many decimal places. Lower the decimal places so that the significant digits and precision is the same. Great. Now just like before, I'm always doing row 8 through row 12. I can be a ninja and drag that function across. Look, all my standard deviations are calculated, and since I had already told it, hey, I only want 2 decimal places, it even kept that and kept that it was center aligned. Woo! I just saved a lot of time. Right? If you wanted to be really fancy schmancy and make this all pretty and add different borders, I could go to borders here, pick all sorts of different options. Boom, here's some borders. Boom, here's some borders. I don't really care that much about that right now, guys. But if you're really into being fancy schmancy, go for it. I do think it's pretty, but it's not the most important. Here I've highlighted the headings for average and standard deviation. I can gray the boxes so they bold more, and I actually can hit the bold button so that it became bold. Now it's a little fancier. Alright, so that looks nice, but the really more important thing we want to focus here on at the end is we got to make our graph. And we got to only graph the averages. We got to select the right type of graph. We got to double check that it's right, because guess what? There's nothing to compare with this time. So remind me, when I'm doing this, do I highlight or graph standard deviation? No, I don't, right? I'm only going to graph the distances and my averages, right? My IV and my DV. All right? So when I have those two things highlighted, I go Insert, Chart. Woo! Ugly. This one's not so good to begin with. Goodness gracious, Google Sheets. Alright, so we got to teach Google Sheets a lot in order to fix this. Alright, so we can try a couple things. First of all, what kind of chart did we think we wanted anyways? Did we want a bar chart? No, we have a IV that's quantitative. So we already know that this is wrong type of chart. We're going to scroll down. We want a scatter plot. Woo, that still doesn't look good. It's okay, we'll fix it. Now we're going to try the switch rows and columns thing. Ooh, look how much that changed. I'll do that again so it goes back. What the heck? Right, this is what we started with. Oh my goodness gracious. All I had to say is, hey, I wonder, Google Sheets, did you get the IV and the DV backwards? And a hint that that happened was, I see 0, 5, 10, 15, 20, 25. That's my levels of IV along the transect, and it's on the wrong axis, right? My IV is always on my x-axis, and these look like pH values, and they're on the wrong axis too. That was a good hint. Plus, it was really an ugly looking graph. And look, when it switched, that's what happened. All right, of course, I had to kind of know my data a little bit to know that, all right, because there weren't any axes labels yet. We're going to add those in. Really cool. We could say use column B as headers. We can see if that helps. Nope, it didn't. That one didn't help at all. All right, so now we're going to customize and try to make it better looking, okay? So we're going to go to legend. Do we need that legend? Is it really going to tell me, do I have multiple scatter plot series? No, I only have one average that I'm graphing, so I can get rid of that guy. Bye-bye, legend. You're so beautiful. All right, we're going to add the axes titles. Now remember, we decided we don't do a chart title in the actual figure itself. We can add it onto the Google Doc later. If we have time, we'll do that. I'm going to add a horizontal axis title. Remember, this is distance along a transect in meters from a stream even better if I had the error on my meter measurements, probably plus or minus 0.05 meters. Something like that. Okay. So now I know what that axis tells me. Let's do the next axis, vertical axis. What was that? All right, it's soil pH. Be careful, it wasn't water pH. And it was for n equals 5 trials. But guess what, Clausen? You forgot. These are averages. Average soil pH. All right. And then we also want to note the error on the probe. Plus or minus 0.05 milligram. Nope, no units on pH. Uncertainty for pH probe. Super long, but gets me a lot of information right there. All right, so now I have my axes really labeled. Now, how do I add my error bars again? That was hiding under series. All right, so I can click add data labels. That's kind of nice. Tells me the actual average is right there on the graph. It can make the graph look really busy, so if your graph starts to look busy, take that away on your actual IA. But we're going to add error bars because that's required for us. Now again, remember the default is percentage. That doesn't make sense here. All right, and so what I can do is I can go back and kind of move my chart off to the side, and I can decide, okay, so this time my standard deviations, this bottom row, are not that consistent. However, they tend to be about 0.25, all right, or so. They can be higher than that, but I could decide to actually average them all and put that amount. I could pick the highest amount. I could pick the uncertainty on the pH probe. So let's try a couple of those things. Let's do the uncertainty on the pH probe first. That was the uncertainty on the pH probe. Notice that that's really small. So that's probably unlikely that was the real error that we probably should account for to see if our error bars overlap. So I'll let you know I did the averaging of all the standard deviations. The average was 0.27. And that is a little bit more realistic, that there could have been some error in how I sampled or in the probe or in all sorts of things. So that's a little bit better. So we're going to go with that and rationalize that in our IA. All right, and we can talk about how some of these overlap, but not all of these. And since this is a scatter plot, the last thing I need to do after error bars under this series heading is I actually need to go find trend line. So I click on trend line, last thing, and I need to actually show the R squared. Now to pick the correct type of trend line, right now it's defaulting to linear. I actually want to maximize the R squared to be as close to 1 as possible, because remember, closer to 1 means the line of best fit is really modeling or showing the actual trend in the data. Because this is saying, is there a negative constant decrease as I move further away? Kind of, but not really, because this is kind of close to 0. So I can change this to be, instead of linear, exponential. That made it go up a little bit. Can barely see the difference. What about polynomial? So this is polynomial 2, and that's actually the only polynomial I'm going to let you guys use, because it's a quadratic. It just means you're doing a quadratic formula. Yeah, math. All right, and it just makes this kind of curve a little bit. All right, which is a little unusual, but it does maximize this to be a little bit higher. So what this says is that maybe really close to the stream, the pH is high, but also a bit higher, and really far from the stream, the pH kind of starts to creep up again too. That's what this shape means. Now remember, this isn't that close to 1, so that doesn't mean this is for sure the best trend line either, but at least it's better. All right, so we actually finished. That's great. The last thing we could do is practice doing a figure title. So we would say figure 1. We would But we actually just ran out of time, so pretty much you would include the units, the uncertainty, just like all of the table titles, and be as detailed as possible, but also what you pick for your error bars. Wonderful job.